Okay, so let's go over the answers to what was on pages 35 and 36. It's going to take me a moment to get to the iPad screen. All right, so, oh, there's where the full screen is. Okay, sorry. So, the first one is 1 kilogram book is resting on a tabletop. So we've got a 1 kilogram book, it's at rest, and it's on a tabletop. So we're going to go ahead and start like we've done previously. So I'm going to put 1 kilogram here. It's at rest, so we know that all of our forces are 0. And we can do our forces. We've got force of gravity. We've got the normal force. I'm sorry, now you're stuck with my handwriting because I'm going to try this. My daughter was writing before, and her handwriting is way better than mine. So force of gravity equals mass times g. So we've got 1 kilogram times 10 meters per second squared, and that equals 10 newtons. So we've got 10 newtons here. And we know that it's balanced, so we have 10 newtons up there. So that is our answer for that one. So number 2, we have a 5 kilogram flying squirrel flying from a tree to the ground at constant velocity. Consider air resistance. A lot of times we're told to neglect air resistance, but this time they want us to consider it. So we've got diagramming the forces acting on the squirrel. So starting out the same way, we've got 5 kilograms here. We know we have the force of gravity. We also know that we have air resistance. And because it is flying from the tree to the ground, air resistance is going to be opposing it. Since it's at constant velocity, we know that our net forces and our net accelerations are all equal 0. So now it's just a question of solving for the force of gravity, which equals mass times gravity, which equals 5 kilograms times 10 meters per second squared, and that equals 50 newtons. So we've got 50 newtons for the force of gravity and 50 newtons for the force of the air due to the air resistance because it is balanced. So then number 3. An egg with a weight of 0.1 newtons is free falling from a nest in a tree. And we're going to neglect the air resistance. Diagram the forces acting on the egg as it's falling. So we know here that we have the force of gravity. We know that it is 0.1. We don't use air resistance, so this is the only force we have acting on this. And because it's free falling, we know that we're going to have the acceleration due to gravity acting on it. So it is going to be 10 meters per second squared down, and there's nothing in the x direction. So now we can find the force of gravity is equal to mass times g, which equals 0.1 kilograms times 10 meters per second squared, which equals so just to let you know, I made a mistake here. So this is incorrect. So what it really told us was that the weight was 0.1. The weight is 0.1, not the mass. So now I actually figure out what the mass is. So the mass in this case is, we still know that weight equals mass times g. If we rearrange this for mass is equal to weight divided by g. So that's 0.1 newtons divided by 10 meters per second squared. So it's going to be 0.01 kilograms. So I don't know that I can write that in there, but it's going to be 0.01 kilograms. So our net force, we're going to have to solve using Newton's second law of motion. We've got net force equals m times a. So the mass here is equal to 0.1 kilograms. It's going to be 10 meters per second squared. And so we are going to get 0.1 newtons. Now you can ask me, how do you know that the AY is 10 meters per second squared? Well, let's assume that you didn't know that. Let's assume that you didn't know this. And instead, this is where you got on the problem. So you recognize that the force of gravity was acting downwards. It was 0.1 newtons. You solved for your mass. It was 0.01 kilograms. Let's say you got to this far. Well, if you got this far, you could also look at it and say that the net force is downward and it's this 0.1 newtons. And then you could find your acceleration. So your acceleration equals your force divided by your mass. You have 0.1 newtons divided by 0.01 kilograms, and that would end up giving you 10 meters per second squared down. So either way you solved it, you would still end up with the same answers, whether you recognize that free falling means that the only thing is gravity, and so the acceleration has to be done is 10, or you do it the opposite way. Okay, so the number 4, a 2 kilogram bucket is tied to a rope and it's accelerated upwards at a rate of 1.5 meters per second squared. Diagram everything. All right, so, and it says to neglect air resistance. All right, so we've got the force of gravity acting on our 2 kilogram bucket. It has no air resistance, but we do have a rope. So a rope says we've got the tension force acting up. There's no forces in the horizontal direction, so those are going to be 0. So figuring this out, it says an acceleration at 1.5 meters per second squared, and it's going up. So we know our net force is also up. So our force of gravity is equal to mass times g, which is 2 kilograms times 10 meters per second squared, which is equal to 20 newtons. So since we have an acceleration, we don't know, they're not balanced, so F tension we don't know. So if we find F net equals m times a, so that equals 2 kilograms times 1.5 meters per second squared. So that ends up being 3 newtons. So that ends up being 3 newtons, and it's upward. So F tension minus F gravity has to equal 3 newtons. We don't know what F tension is, but we know gravity was 20. And so then we can solve that F tension equals 23 newtons. All right, let's go on to number 5. So number 5, a 2 Newton force is applied to a 1 kilogram book in order to move it across a desk with an acceleration of 0.5 meters per second squared. Consider friction, neglect air resistance. So we have a 1 kilogram book, we have the force of gravity, we have a normal force, we have, I'm going to say it's going to be applied and moving to the right because it didn't tell us. It says consider friction, neglect air resistance, or acceleration, and this is going to be in the x direction, right? So we've got 0.5 meters per second squared going to the right. There's nothing in the horizontal direction. So start out like we always do. F gravity equals mass times G, which is 1 kilogram times 10 meters per second squared, which equals 10 newtons. Since it's balanced in the y direction, we also know that's 10 newtons. I neglected to write that the applied force was 2.0 newtons, but I can include that now. So the net force is equal to mass times acceleration. So mass is 1 kilogram, acceleration is 0.5 meters per second squared. So we've got 0.5 newtons. So that's 0.5 newtons to the right. So now we've got F applied minus F friction equals 0.5. So the applied was 2 minus the force of friction equals 0.5. And that will lead us to the fact that our force of friction is going to equal 1.5 newtons. Sorry, I was running out of room there. All right, so number 6, we have a 1.5 Newton force applied to a 1 kilogram book in order to move it across the desk at a constant velocity. Consider friction, neglect air resistance. Okay, nice. We've got a constant velocity problem, so that means all of these are 0. That's really nice. Okay, so we've got a 1 kilogram book. We have the force of gravity. We have the normal force. We have an applied force, and it tells us that that's 1.5 newtons. We have a friction force that it tells us to consider. And that's it. So F gravity again equals mass times G, which equals 1 kilogram times 10 meters per second squared, which equals 10 newtons. So we know that the force of gravity is 10 newtons. It's balanced by the normal force of 10 newtons. And since we know the rightward force is 1.5 and it's balanced, the leftward force is 1.5. That was an easier one. So let's move on to number 7. A 70 kilogram skydiver is descending with a constant velocity. So we have constant velocity, consider air resistance, diagram the forces acting on the skydiver. So he's 70 kilograms. We've got the force of gravity. We've got the air resistance. We've got constant velocity, so it's all 0. So in this case, the force of gravity equals mass times G, which equals 70 kilograms times 10 meters per second squared, which equals 700 newtons. That was really poor writing. Equals 700 newtons. So we've got 700 newtons down, and we've got 700 newtons up. Number 8. 30 Newton force is applied to drag a 20 kilogram sled across loosely packed snow with an acceleration of 1 meters per second squared. Diagram the forces acting upon the sled. So we've got a 20 kilogram sled. We've got the force of gravity. We've got a normal force. We have an applied force. And they said that was 30 newtons. We've got an acceleration in the x direction of 1 meter per second squared. I'm going to assume that's to the right. So our y forces are all 0. And we are going to end up with a friction force. It doesn't tell us, but I'm assuming it's across loosely packed snow. It's probably going to have some friction, but we'll see what happens. So we're going to start as we normally do. F grav equals m times g, which is 20 kilograms times 10 meters per second squared, which equals 200 newtons. And it's balanced, so that's 200 newtons. Now we've got our net force equals mass times acceleration, 20 kilograms times 1 meter per second squared, which equals 20 newtons, and that's going to be 20 newtons to the right. So F applied minus F friction equals 20. F applied is 30. So we know our force of friction is going to equal 10 newtons. I'm sorry this video is running a little bit longer, but I didn't want to split up the worksheet into two separate ones. So we've got an 80 kilogram car coasting to the right with a leftward acceleration of 1 meter per second squared. Okay. So it's 800. So F of gravity, F norm. It has no applied force. It's coasting to the right with a leftward acceleration. So the fact that there's a leftward acceleration tells me that it is slowing down. So that sounds a lot like friction to me, friction. So let's see what we can do. Force of gravity equals 800 kilograms times 10 meters per second squared. So that equals 8,000 newtons. And it's balanced in the y direction, so that's also 8,000 newtons. So now let's look at our Newton's second law of motion. F net equals 800 kilograms times 1 meter per second squared. We have 800 newtons to the left, and since there is only one force, that one has to be 800 newtons. All right, so ladies, most of the time students really do need a little bit more practice with this before they continue on to the MOP apps. So I'm going to recommend that you do 37 and 38 before you attempt the MOP apps. If you really feel like you don't need to do any more and you want to go ahead and continue on to the MOP apps, go ahead and work on NL7, NL8, and NL9. And if you feel like you're ready and you just want to do the next set of pages here with 37 and 38, I will go over the answers to those in the next video.